has for 2.7 on the notes is pretty much everything you need to do in order for you to graph your function. This simplify f if possible. This technically should be all the way at the very end before the vertical asymptote, but we'll just leave it there and go along. But that technically should be on the very end. Okay, so for 0, oh, it has step 0 missing. I recommend you guys put step 0, which is the domain. It's always important to determine the domain of the original function. So that's going to come up into play on the very last problem. So step 0, finding the domain. In this case, what's the domain of my function?
All numbers except -6.
Very good. So all real numbers.
+6, sorry.
Except +6. Because if x equals 6, you will have undefined in the denominator. You'll have a 0 on the denominator. You can't have that. So step number 1, it says to simplify. Can I simplify 1 over x plus 6, x minus 6? The answer is no. So there is no simplification. So there's none. So go to step number 2. Step number 2 says find and plot the y-intercept, if any, by evaluating f of 0. So to find the y-intercept, what do I have to plug in? 0 for x. Let me put that. Let me not skip steps. Y-intercept. That's step number 2. You find the y-intercept when x equals 0. So f of 0 equals 1 over 0 minus 6. Simplify, -6. So this is 1/6. So my y-intercept is 0, -1/6. What?
The fifth part, but you really need the, no, this is a demo. I was gonna say, you really need to solve for the zeros of the numerator, because you can tell it's 1 over x that it's gonna be 0 after the asymptote, it's gonna be a 0 for the horizontal.
Well, yeah, but the thing is, you'll always want to, what's it called? Yeah, I guess if you do it that way, sure. So for the x-intercepts, so it pretty much you just take the numerator, and what it tells you is to put it tells you to put n of x equal to 0. So remember, n of x is the numerator, right? So it literally just sets it equal to 0. So in this case, you take the numerator, which in this case is 1, set it equal to 0. In this case, 1 does not equal 0. So that means there is no x-intercepts. So you take the numerator and set it equal to 0. That's why it's n of x, and n of x is the numerator of my function. Does that make sense? So that's the algebraic way of doing it. Step number 4, it says to find the vertical asymptote. Find the zeros of the denominator for any by solving the equation d of x equals 0, then sketch the corresponding vertical asymptote using dashed vertical line. So step number 4, honestly, is just the vertical asymptote. So in this case, the vertical asymptote is x minus 6 equal to 0. Then we take the denominator and then x equals 6. So that is my vertical asymptote at x equals +6. Step number 5. Horizontal asymptote. So this is where you compare the ends and the m's. So f of x, 1 over x minus 6. So this is 1 over x times 0, x minus 6. N is equal to 0, m is equal to positive 1, and 0 is less than 1, right? So that means your n is less than m. So what happens when n is less than m? What's your horizontal asymptote going to be? You guys can look at yesterday's notes. What happens when the bottom one is bigger than the numerator?
Um,
You guys said it already. Y equals 0.
I was helping her with her, they're on asymptote over there, and she was confused about it. I just thought of something that'll help like everyone over there with it is, which is the fact that it's always gonna be in this equation, it's always gonna be to find the asymptote, it's gonna be n over m. But when you have n is greater, is has no or n is greater, then you're gonna pretty much have 0, pretty much most of the time.
If n is 0?
No, sorry, if like if n is 0 over m, then it's gonna, the asymptote's gonna be at 0, because that's how that works. Anytime that n is greater than m, the
N or m?
n is greater than m, then the asymptote's at 0. And
But this one's less than though. This one's less than. N is less than m.
wait, but yeah, but 0 over 1 is all the same, because which is the
Oh,
and
okay.
and x, then the first number is gonna be 3 over 2, or like whatever, which, so you could.
Oh, you're doing it that way? Yeah, sure. If you want to think of it that way, yeah. Yeah, you could do it that way. The other way you could think about it is whichever one is bigger. If the bottom one is bigger, it's gonna be y equals 0. If the top one is bigger, then there is no horizontal asymptote. And then if they're both equal to each other, then it's the wherever the leading coefficients are. So that's one way you could think about it. If this is bigger, then y is equal to 0. But if the number in the numerator is bigger, then what's it called? There is no horizontal asymptote. And honestly, when I learned pre-calc, that's honestly how I learned it myself, was just seeing which one is bigger. Because honestly, remembering 0 less than 1, n is less than m, and then
Yeah, it's like if 0 is on top, then it's gonna be 0, and if 0 is on the bottom, then there's nothing, because it's
yeah,
and then
that's honestly fine.
it's one top, then it's whatever the numbers are in front are.
Exactly. Yeah. You could think of it that way. Yeah. Honestly, when you get to higher level math, if the definition that it tells you, like if it's a little bit more complicated or if it's just a lot, you can honestly just make your own way of thinking of it. And that's honestly perfectly fine. A lot of students do it, even teachers do it too. But yeah, that's honestly a good way of determining the horizontal asymptote. All right, number 6. Plot other points. So in this case, it wants you to plot other points. But before we actually do number 6, yeah, kind of want to already graph it. So in this case, we have a um y-intercept going from top to bottom at 0, 1, 6. So it's roughly right here. So we'll say that's 0, negative 1/6. It has no x-intercept, but has a vertical asymptote at x equals 6. So at x equals 6, we'll put dashed lines. Let me do that a little bit better. X equals 6, dashed lines. That means we have a boundary right there. We have a horizontal asymptote at y equals 0, so that means we're going to have a dashed line, a boundary. And then that's pretty much it. That's all we have. So now, when it says to plot other major points, it wants you to plot one coordinate the left-hand side of the vertical asymptote and one coordinate on the right-hand side of the asymptote, right? So in this case, what's one coordinate left-hand of the vertical asymptote and what's one on the right-hand side? So which one would it be? Because I know it's going to cross this coordinate here, but I don't know how low or how wide the graph is going to be. So in this case, you can just pick one digit. In this case, I always pick 1 to the left. So in this case, it's 5. and then 7 because they're both one digit left and right hand of the vertical asymptote. So that means you're going to create a table. I'm going to plug in 5 and then 6. It's undefined. We know it's undefined because we have an asymptote there. And then 7. So all we got to do is just plug it in. So f of 5. Oops. Equals 1 over 5 minus 6, which in this case is -1. So 5, -1 is one coordinate. So 5, -1 is right here. So I can already get a rendition of what the graph is going to look like, which in this case, it's going to bend going left-hand side because it's got to cross the y-intercept that I had initially drawn. And that means when it's going this way, because of that boundary, it's going to curve, but never cross that asymptote. But I kind of need to know what this coordinate was, whether it was here or all the way over here. So it's very important to have that 5, whether it's going to be a wide one or very close to it. So for number 7, sorry, for part 7, we're going to plug in f of 7, 1 over 7 minus 6, which in this case is 1, which is just 1. So 7, 1 is also another coordinate, which is going to be right here. And then because we have boundaries, that means my graph is also going to curve like so, and then curve this way. Now, it's not going to be like a super perfect graph, like if it was on Desmos, but you drew a as accurate as possible graph by hand. On the right-hand side? Yeah, for the most part, yeah. Yep. Yeah, it's honestly when it comes to just when it comes with these ones, you'll see there's one graph you do need 3 points, but for graphs like this, it's you technically just need 2. No, this one when it has when you have 2 vertical asymptotes, you'll see.
Oh.
And then honestly, we have 3 coordinates. We have this coordinate right here, 7, 1. We have this coordinate 5, -1, and we have 0, -1, 6. So it still pretty much follows the whole, like when you graph something, you want to have at least 3 coordinates. You still have 3 coordinates, you know? Does that make sense? Because honestly, if you want to put 5.5 or 5.9, stuff like that, then that's perfectly fine too. But honestly, if you try to put any of these coordinates, it's gonna be like all the way down here too as well. So like, because it's gonna have you like graph it like super, super close, but it's honestly just the same thing. But here's the thing, you have 3 perfectly good coordinates: 7, 1, 5, -1, and 0, 1, 6. Even though that 0, 1, 6 is kind of like, very small, it's still possible to graph. Does that make sense? So when you're doing these, you can use Desmos to double check your work. So let me pull up Desmos real quick.
Like 3 points if there was no horizontal asymptote as well, because it's
Yes.
not gonna curve the same way.
You should always have 3 coordinates. Okay, there we go. Yeah, I need to share the screen for this. Okay. So we're gonna graph, was it 1 over x minus 6? So that's our graph. Plot our asymptote. We have x equals 6 right there. Y is equal to 6. Oops, sorry. Y equal to 0. My apologies. That's the horizontal asymptote. And then plot the coordinates 0, comma 1, 6, or -1, 6. My apologies. -1, 6. And it's right there. So that's 0, 1, and 6. And then we have, what was it, 5, -1? 5, -1. It's right there. Label it. And then the last one, which is 7 comma 1. Oops. And there you go. We looks like a pretty looking graph. So looks pretty accurate. You did it by hand without having to use Desmos, but you can definitely use Desmos to make sure double check your work to see if you actually got it correctly. Does anyone have any questions? I mean, it's our graph is pretty good, pretty accurate. Yeah. The notes will be on Canvas, Tristan. You left on number 1. All right, let's do the next one. So we're just practicing. Okay. So let's do this one. 2x over x squared plus x minus 2. So we're gonna follow the steps. Step 0, find the domain. This is gonna come up a lot in the next one. So not this one particularly, but for the next one. You're close. X squared plus x minus 2. You have to factor that.
Oh,
X is positive 2, x minus 2. So x cannot equal negative 2 and x cannot equal positive 1 for the domain of my function. Oops, I kind of erased my part. Hold on, I gotta probably bring up my notes. Oops, wrong one. No. Oh, here it is. So that's the domain. Part 2 is to simplify. Sorry, part 1. Sorry. Simplify. In this case, we have 2x and then the factored form of the denominator. X plus 2, x minus 1. Unfortunately, we can't simplify. We can't reduce. So no reduce. So number 1 is already done. Number 2, find the y-intercept. So remember that you find the y-intercept when x equals 0. So f of 0 is equal to 2 times 0, 0 squared plus 0 minus 2, which in this case is just 0. So my y-intercept is 0, comma 0. Why? So for number 3, you find the x-intercept. So the x-intercept is when you set the numerator equal to 0. In this case, to solve for x, you divide by 2, divided by 2, x equals 0. So that means that when you plug in 0 for y, x is 0. So the x and y intercept are the same. Do you guys have any questions so far? Okay, I'm gonna ask, please. I'll put on the right hand side. For number 4, vertical asymptote. So remember, for the vertical asymptote, you set the denominator equal to 0. So x plus 2, x minus 1, x equals negative 2, x equals positive 1. So those are my horizontal vertical asymptote. So if it doesn't simplify, technically your domain is your vertical asymptote. But remember what we learned yesterday, what happens when we do simplify? They're not the same. Yeah, so you gotta be careful. Number 5, horizontal asymptote. So we have 2x over x squared plus x minus 2. So n is equal to 1, but m is equal to 2. So what happens when the bottom one is bigger than the top? Okay, there you go. And then equal to 0. So my horizontal asymptote is 0. So when m is, oops, should be the other way. When m is greater than n, my horizontal asymptote is y is equal to 0. Up. Mm-hmm. Step number 6 is plot coordinates. But for step number 6, you kind of have to plot what you got. So, vertical asymptote at x equals -2. So I'm going to draw an asymptote. I have an asymptote at x equals +1 for my two verticals, and then I have one horizontal asymptote. I have an x and y intercept at 0, 0. So this coordinate right here. Okay. So for this one, you are going to have to plot a couple of coordinates. You're going to have to plot one coordinate left hand of this vertical asymptote, so at -3. And you're going to have to plot one on the right hand side. You're going to have to plot -1. So -3 and -1. But then on this vertical asymptote, you're going to plot one on the right hand side, which is 2. And then you're going to have, you don't necessarily have to, because once you plot this one, you'll see how this one falls too. So first we'll do -3. -3, so f of -3 is equal to 2 times -3 divided by -3 squared minus 3 minus 2. When you do the math for this, I already have the notes for it. So you get -1.5. When you plug in -1, 2 times -1, parentheses, -1 squared, minus 1 minus 2, you're going to get +1. So you can just plug this one on the calculator. So I'm just going to give it the numbers already. Then we're going to plot the coordinate between 0, 0 and 1, 1. So in this case, it would be 0.5. 0.5. So f of 0.5 is equal to 2 times 0.5, 0.5 squared plus 0.5 minus 2. When you do the whole math for it, you will get -0.8. And then for the next one, plot 2. What's up?
At 0, 0, it would be 0 counter. Yeah, wouldn't it like be 0, 0, but we have a horizontal or
So remember how I told you yesterday, there are some exceptions, and you'll see right now. +2 plus -2, sorry. -2 is equal to you get 1 for this. So we have our coordinates -3, -1.5, -1, +1, 0.5, -0.8, and then 2, 1. So we had to plot 4 coordinates. So give you guys a chance to write it all out, and then we'll plot it. You guys have any questions so far? Okay, so -3, -1.5. It's roughly right here, kind of, so right here. -3, -1.5. -1, 1, so that's right here, -1, 1. And then at 0.5, -0.8. So let's say it's roughly right here. So, and then 2, comma 1. So for the left-hand side, we have something that looks like this. We know it's gonna, oops, it's gonna look like this because we got the boundaries, right? For the one in the middle, we know we have the x-intercept 0, 0, so it's going to bend and then bend right here.
So in the middle, we just ignore the asymptote.
Yep,
Oh, okay, that's.
because there's some exceptions, and that's why it's important to graph at least a couple major coordinates. Unless you have a domain restriction, so you kind of have to be very, very careful with it.
It was like +1, and it wasn't. Yeah.
So let's graph it. Let me.
It needs a +2 or something, yeah. In which case, it probably just shoot out of the direction.
Okay, so let's graph it on Desmos and let's see how accurate we are. So we have oh, you're right. Well, I'm getting the wrong one. Yeah, 2x x2 minus 2. We have our asymptotes at x equals -2, x equals 1. We have a horizontal asymptote, y is equal to 0. We have the following coordinates. Hold on, -3, comma, -1.5. That's the first one. And then we want to make sure we label it. Where's my, okay. Right there. 0, 0. Oh, sorry. -1. Oops.
There's no measurement sort, there's no way.
-1, 1. 0, 0. And then this one we got 0.5. Oops. It's perfectly right there. And then and look at that. We drew a perfectly looking graph. If you ask me, it looks like everything is what we did on our paper, similar to what Desmos has. All of our intercepts that we found, all the boundaries we found, all the coordinates that we plugged in was sufficient enough to get as accurate possible graph we had. We have this bend right here. We have this portion of the graph crossing the boundary. So that's why you kind of have to be very careful. Sometimes, for the most part, the boundary will be there for you to know that you're not crossing it, but there are some exceptions. So in this case, this line going through the middle of the x and y intercepts, so of the vertical asymptotes, does indeed cross. So you can have to be very, very careful. And our first rendition that knowing that it was going to cross was the fact that the y and x intercepts was the same as our horizontal asymptote. So I knew it was going to cross. So that's why I knew I couldn't just go and bend it. I had to pick a coordinate here, and it turns out it does go through the um the horizontal asymptote. So I had to keep it going. So that's why you go all the way down. Because if it did bend upward, then it would bend, but it didn't. It went perfectly lined going through. And then for this, it was a regular boundary. So make sure if you have two horizontal asymptotes, and you might want to do a couple coordinates inside just to double check to make sure it actually goes through. So yeah. All right, last one, and then we're done. Stop sharing.
Super simple. It'll probably be that x plus 4/1.
Okay, the last one is in fact the easiest one, but also the trickiest one. It's the one that a lot of students lose points on because they don't remember the important stuff. So for this case, so we have the function x squared minus 16 and x minus 4. First things first, always do the domain. I don't know why it doesn't have in the beginning, but you should always find the domain. In this case, what's the domain of this equation?
X with restriction of 4.
X cannot equal positive 4. So all real numbers, and this is gonna play play an important role in this one. Numbers except x equal to 4. Step number 1 is simplify. In this case, it does simplify, which is okay. That yeah, well, yeah, that's the answer. But you have to yeah, yes, because those both get factored out. So we have x plus 4. For step number 2, when it's specifying the y-intercept, you can use a simplified form. I don't know why it said you're supposed to do simplify at the end. I made that wrong mistake. You're actually supposed to simplify from the very, very beginning. So make sure you simplify first. So in this case, well, technically you don't have to, but it makes it a lot easier if you do. So x plus 4, so remember we have what was it, the y-intercept? I'm looking at the wrong folder. When x is equal to 0, so f of 0 is equal to 0 plus 4, which in this case is just 4. So we have the y-intercept of 0, comma 4. And you can use the simplified version. You don't necessarily have to use the original equation, but you can if you want. Step number 3, the x-intercepts. So we're going to set x plus 4 over 1, right? Because this has an imaginary 1 in the denominator. So that means I can take my numerator, x plus 4, equal it to 0. This means that x equals negative 4, y is equal to 0. So my x-intercept is negative 4, 0. And you can double check this. Plug in negative 4 into this equation, and you will indeed get 0. So you can double check your work if you want. But yeah, that's the x-intercept. You take the numerator equal to 0. So we can put this imaginary 1. So x plus 4 equals 0. You just take the numerator is equal to 0. And then you can double check by plugging it in. Step number 4. Vertical asymptotes. So in this case, remember, for vertical asymptotes, you take the denominator equal to 0. In this case, this is not true. So there is no vertical asymptote. Okay, maybe it was important to simplify. Okay. Vertical asymptote, there's none. Step number 5, horizontal asymptote. It would be, yeah. So x plus 4 over x over 0. So n is equal to 1. M is equal to 0. So in this case, n is bigger than m. Or in this case, if the top is bigger than the bottom one, no horizontal asymptote. Any questions on number 5? Okay. At number 6, we're gonna draw a grid. Okay, so we have a y-intercept of 0, 4, which is right here. We have a x-intercept at -4, 0. Okay, so -4, 0, 0, -4. And then we need one more coordinate. What coordinate do we pick? There is no vertical asymptote in this case. So what coordinate should we pick for a third coordinate? 5. So f of 5 is equal to 5 plus 4, which is 9. Okay. So now we're going to connect the dots. There's no vertical and there's no horizontal asymptote. So that means I could just draw a line, right?
So what's the part that people are gonna mess up on this?
Okay. What was the domain for our original equation? What could x not equal? 4. So at x equals 4, you're going to have to put an open circle because that is undefined. So undefined. So now remember, our original equation is x squared minus 16 over x minus 4, right? We use the simplified version to get the rest of the stuff. But the thing is, you're going to have to be very careful because even though you could just plot this using slope-intercept form, you have to take into account that this is the original equation with this domain. This doesn't have a domain restriction, x plus 4, but the original one does. So if you actually go on Desmos and graph it, you're going to have to graph the original equation. So in this case, your fourth coordinate for when you draw the table, oh, actually, no, not the table, but for the original equation. Um, okay, sorry, not here. Okay, so okay, so then we're gonna so this is where you kind of have to be careful. Oops, I went out too fast. It was x squared, right? So look at that. We have pretty much what we have. So we had -4, 0. That's correct. 4, comma 0. Oops, no, was it? It was 0, comma 4. Sorry. Label it and label this one. But the thing is, at x equals 4, yeah, you're gonna have to bring up the table. Oops. Here it is. When you plug in 4, you will get undefined here. So this is the original equation that we're graphing at. 4, you're going to have undefined. And let me see if it actually pops up. Where's 4? Yeah, see?
Oh,
Oh, there you go. See, at 4, it's actually undefined. So you actually have to put a open circle at 4, comma 0, because the original equation has a domain restriction of x cannot equal 4, but we can use the simplified version of y equals x plus 4 to get pretty much use that equation to graph it instead of using the original equation. Does that make sense? You guys have any questions? Yeah, so that's why we have x, we have a domain restriction of 4, 0. So if this one does end up happening on a test, I will be expecting you guys to put a circle at any domain restrictions of the original equation, not the simplified equation, because that's the accurate graph of your the equation. So be very careful. Those are the tricky ones. So on the notes, oops, this has to go over here, otherwise it's not going to work. Okay, cool. So for this one, I will be expecting you guys to write 4 comma undefined, because it does have a open circle at x equals 4. So that's pretty much it. So that's our accurate picture. We got 3 coordinates, and then we technically had to get the 5th one, which is this undefined coordinate right here, which is comes into play. So definitely do not sleep on step 0, because it does come into play in the final graph. All right, good job, you guys. That is it. That is chapter 2. We are officially done with chapter 2.
Good question. How much,